Hi students, today we're looking at the lesson Similar Triangles and Slope. Your learning target is I can find the relationship between the slopes of similar triangles. For this assignment, you will need pages 125 or through 126 or these video notes if you don't have your book. Again, I wanted to emphasize that this is an optional video, but before you turn the video off, if you do not watch this video, you still have to complete pages 125 through 126 and turn those pages in class. This video will be going over how to do those pages. So if you need a refresher on how to do those pages, you can follow along with the video. Otherwise, you can just end the video now and complete pages 125 through 126 at home. Okay, so before we go on, let's go ahead and review the properties of similar triangles that we already know. Take a moment and pause the video and write down as many properties as you can remember in this column, and then draw a line underneath what you remember. All right, so make sure you draw that line underneath what you remember, and then go ahead and write down what I am writing down, or if you wrote this down already, good job. I want you to remember that there are a few things that we can use to determine if a triangle is similar. We can use the AA postulate, and I'm just going to abbreviate it, AA postulate. And the AA postulate, it stands for angle, angle. So that means we need two angles to be the same in two different triangles to prove that they are similar. So we can have one triangle or one angle be the same for 90 degrees, and maybe this one up here is 30 degrees or 60 degrees. And they're both going to be the same. So by the AA postulate, these two triangles are similar. Okay, then we also have the side, side, side angle, or the side, side, side postulate. And like those creative mathematicians, side, side, side stands for the three sides of a triangle. That's why there's the three S's. So if you have the side lengths of two different triangles, and you know that they are proportional to each other, then you can determine that those two triangles are similar. And this is where we usually mark the 1, the 2, and the 3 tick marks to show which lengths correlate with each other. And then just remember, I'm going to write it in here, that they are proportional. Okay, so this is what you should know already before moving on with lesson 5.4, or our slopes and similar triangles. So let's go ahead and move on with this new lesson. And I'm starting on page 125, the Explore number 1. And it says that the graph shows the linear function y equals negative 2/3 x plus 4. Okay, and just a refresher, this is our slope, this is our y-intercept, and it is graphed on our coordinate plane. And I'm going to get a line to draw it. It goes just about like this. Okay, and then this right here would be 4. So this would be our 4, this is our y-intercept, and then the rest I just estimated. But in your book, it is just like that. And again, if you're watching this and following along in your book, just write what we're writing in your book. You don't have to write these notes also. Okay, so first it's asking us for letter A. It's asking us to find the slope of the line using the points 0, 4, and negative 3, 6. 0, 4, and negative 3, 6. All right, and we know that we can find the slope using 2 points because we know that we have the formula y1 minus y2 over x1 minus x2 is going to equal m, or is going to equal our slope. So y1 minus y2 over x1 minus x2 equals m, equals our slope. So take a moment, plug this into your formula and see what you get for your slope. All right, hopefully you plugged this in and you did, the blue boxes would be 6, take away 4 over -3, take away 0, and you'd get 2 over -3 or -2/3, which is right because we found this is our slope and we know that this was our slope just by looking at the equation. All right, and then moving on to letter B. B is asking to find the slope of the line using a different set of points on the line. And this is just checking that you know that you can use any point along this line, any 2 points along this line, and you should find a correlation between the slopes. So go ahead and choose any 2 points that you would like to on the line and check the slope on them and make sure that they're perfect points. Remember, perfect points, they cross through an intersection of 2 lines perfectly. They're not just like somewhere in the middle that is going to be hard to calculate. They're going to be crossing through exactly on 1 point. So go ahead and do B on your own and then pause the video and come back for letter C. And if you're back and we're working on letter C is actually the same exact thing as B. Go ahead and choose 2 more points and check that slope as well. All right, and then once you're finished with that, we're going to look at the reflect questions on 1A and 1B. So question 1A, what does slope represent? Tell me what, in your own words, what does slope represent? We know how to find the slope, but what does it mean? Why do we use it? Tell me at least in one sentence what slope represents. Then for 1B, does it matter which pair of points you use when you find the slope of the line? And explain why. Did it make a difference when we used this point and this point versus this point and this point, or this point and this point? Tell me if it made a difference when you solved for that equation. And if so, tell me why. If not, tell me why. This should at least be a yes or a no question and then an explanation sentence after that. All right, and now we're working on page 126 on Explore number 2. And it's asking us to use similar triangles to explain slope. So on your page, you should have a line. I'm sorry, it's actually not on your page. We're going to be drawing this. So on step A, you have a box. Let me draw the box. You have a box on your page. It looks like this. And on letter A, it tells you to draw line L that is not a horizontal line. So remember, horizontal means that it goes across like this. We need a line that does not go across like this. So we need a line that's going to be anything but horizontal. And I would also prefer that it is not vertical, meaning that it's not straight up and down, just that it's on some sort of angle. And I'm going to draw mine just like this. You can draw yours however you'd want to, though. All right, and then it says label 4 points on the line as A, B, C, and D. So you'll need your pencil, and I'm just going to label 1, 2, 3, 4 points, and then I'm going to label them A, B, C, and D. All right, and then it says on question A, you need to show that the slope between points A and B is the same as the slope between points C and D. So I need to show that this line right here and that this slope right here, the 2 slopes between those points, are going to be the same. All right, so first we need to go ahead and follow along with section B. So on section B, it tells us to draw the rise and the run for the slope between points A and B. And just because I labeled my points at the top, I'm just going to draw the rise and the run underneath the points. You can draw them on the top if you want to. So here's my run for A and B. And here's my rise, which is actually a fall. but that's okay. All right, and then here is my rise or my run for C and D, and my rise for C and D. All right, so it says to draw the rise and the run, which I just did. And then it says to label the intersection of the rise and the run. Here's my rise, here's my run, here's my rise, here's my run. To label the intersection of points E and F. So here's point E, and this is point F. All right, so go ahead and label those now. And then section C says to write expressions for the slope between A and B and between C and D. So to do that, remember our slope is rise over run. So our rise here is BE. This is our rise. So we're going to do rise is BE. Therefore, our run is going to be AE. All right, so here's AE, and our slope is BE over AE. And then this guy, CD, our slope between C and D is going to be, the rise would be DF, because here's the rise, and then our run would be CD, or CF, sorry, CF. Right, then the next step says to extend line AE and line CF across your drawing. So let's do that first. Extend line AE and line CF. So I'm just going to take this, extend line AE right here, and then extend line CF. I'm actually going to start it over here and do it all the way across the drawing. All right. Oh, look. Oh, sorry, that one's not supposed to be there. Delete that. All right, so extending line AE and CF. So they're both horizontal lines, so they're both parallel. Now mine aren't drawn perfectly, but remember we can avoid human error by just writing that they are parallel right here. And line L is a transversal that intersects parallel lines. Now if you forget which one line L is our original line right here. This is line L. And now this is a transversal that intersects parallel lines, and I'm going to extend AE all the way across a little bit more. All right, so then it says complete the following statements. So we're looking at angles now instead of lines and triangles. So angle BAE and angle BAE. So that's talking about this one right here, angle BAE and blank are corresponding angles. So which angle has the same location as this angle up here? Well, it's DCF. If you look, angle DCF and BAE are going to be corresponding angles. They're in the same place, they're just on different sides of the parallel line. Then that means they are therefore not the same, but the math word is congruent. That is a very sloppy way to write congruent, so I apologize, but they are congruent. And then do that again for angle BEA, this angle, and the other angle you need to find are right angles. So find another right angle up here, and because they're right angles, they will also be congruent. And then letter F through letter I, you can complete on your own. You just think about the postulates that we've already talked about. And think about the angles that you can find in these triangles, and think about the rules that we know when we're working with parallel lines. So again, complete F, G, H, and I on your own, and I think you'll be able to do it once you start putting all these pieces together. Remember, this is all to prove that the slope between A and B and C and D will be the same for similar triangles. All right, and then don't forget that when you are finished with this video, you should have at least pages 125 through 126 completed so that you can turn these in and bring them to class the next time I see you.